The discovery is historic. Welcome to Waves Discovery, and today we're counting down our picks for the top 10 astronomy discoveries. This list highlights the all-time biggest discoveries in astrophysics and cosmology. What new discovery do you hope to see in your lifetime? Tell us in the comments. Number 10. Jupiter's moons. In 1610, one of the most influential astronomers in history, Galileo Galilei, observed 4 strange objects orbiting Jupiter through his telescope. These objects turned out to be Jupiter's 4 largest moons: Ganymede, Callisto, Io, and Europa. Aside from Earth's moon, this quartet became the first moons ever discovered in the solar system. Thanks to their enormous sizes, Ganymede and Callisto are both comparable to planets. Today, Jupiter's moons are still among the most intriguing bodies in our solar system, with Europa's subsurface oceans potentially capable of hosting alien life. Number 9. Uranus. It's hard to imagine a time before we knew about the 8 planets in the solar system. However, Uranus and Neptune are difficult or impossible to see with the naked eye. Humans could observe Mercury, Venus, Mars, Jupiter, and Saturn long ago, but it wasn't until 1781 that Frederick William Herschel spotted Uranus using a telescope he built himself. It took another 65 years for Neptune to be discovered, and in 1930, Clyde Tombaugh observed Pluto. Although Pluto was initially considered a planet, it was later reclassified as a dwarf planet and the first known trans-Neptunian object, which is exciting in its own right. Number 8. Stellar nucleosynthesis. What makes stars shine? Stars are primarily composed of hydrogen, the lightest element in the periodic table. Through nuclear fusion, stars convert hydrogen atoms into helium and eventually into heavier elements. This process not only fuels stars but also produces the energy they emit. When stars run out of hydrogen, they die. The theory of stellar nucleosynthesis was first suggested by physicist Arthur Eddington in 1920, and subsequent research confirmed his ideas. This process is why all life on Earth is composed of stardust. Number 7. Other galaxies. The Milky Way, our galaxy, is vast, estimated to span more than 100,000 light-years and containing billions of stars and planets. It is a spiral galaxy, and what we see in the night sky is our place within this giant disk of stars. However, it wasn't until the mid-1920s that we confirmed the existence of other galaxies. The Andromeda Galaxy, or Messier 31, was the first galaxy discovered outside the Milky Way. Although it has been visible to the naked eye as a faint smudge in the night sky, Edwin Hubble determined it was a separate galaxy, not a nebula as previously thought. This discovery revolutionized our understanding of the universe, revealing that there could be countless other galaxies beyond our own. Number 6. Black holes. In 1916, Albert Einstein published the final form of his theory of relativity, recognizing that gravitational fields are equivalent to the concepts of space and time. Among his equations was the prediction of black holes, or Einstein-Rosen bridges, which might even serve as gateways to parallel universes. Although Karl Schwarzschild found a solution to Einstein's theory in the same year, it took 50 years before the first black hole, Cygnus X1, was observed. In 2019, the Event Horizon Telescope captured the first image of a black hole, marking a monumental achievement in astronomy. Number 5. Dark matter and energy. Although dark matter remains hypothetical, it provides the best explanation for the structure and behavior of galaxies. Evidence from the cosmic microwave background, the afterglow of the Big Bang, supports the existence of dark matter, which is believed to account for approximately 85% of the universe's mass. Dark energy, on the other hand, is theorized to be a force that accelerates the universe's expansion. Observations of distant supernovae indicate that the expansion of the universe is speeding up, matching the effects predicted if empty space itself had a small amount of energy. Number 4. Redshift and blue shift. One of the key reasons we know the universe is expanding is the phenomenon of redshift. As large objects in space move away from us, the wavelength of their light stretches toward the red part of the spectrum. This stretching indicates how fast an object is receding. Conversely, blue shift occurs when an object moves towards us, causing its light to shift toward the blue end of the spectrum. The Andromeda Galaxy, for example, is approaching the Milky Way and will eventually collide with it. Number 3. Hubble's Law. In 1912, astronomer Vesto Melvin Slipher discovered that distant galaxies are redshifted. In 1929, Edwin Hubble used this data to demonstrate that the universe is expanding and that this expansion is accelerating. Hubble's law states that galaxies are moving away from Earth at speeds proportional to their distance. This finding revealed that the further away a galaxy is, the faster it moves away. Hubble's work led to the determination of the Hubble constant, providing precise measurements of the universe's age, approximately 13.77 billion years, and deepening our understanding of cosmic expansion. Number 2. Cosmic microwave background radiation. The Big Bang was an explosion of unimaginable scale and force, leaving behind residual radiation known as cosmic microwave background radiation, CMBR. This radiation, emitted during the early expansion of the universe, has been stretching out ever since. Although predicted by Ralph Alpher and Robert Herman in the late 1940s, CMBR was discovered in the 1960s by Arno Penzias and Robert Wilson, who were conducting satellite communication experiments. Their unexpected finding confirmed the theory and became a cornerstone of cosmology, earning them a Nobel Prize. Before we unveil our top pick, here are a few honorable mentions. Kepler's laws, which were crucial for understanding planetary motion. The observation of gravitational waves in 2016, which revealed ripples in the fabric of space. Radio astronomy, pioneered by Carl Jansky, which has become a key tool for studying the cosmos. The discovery of liquid water on Mars in the 2010s. And the detection of organic molecules on comets in 2015, suggesting life on Earth might have originated from outer space. Number 1. Heliocentrism. While it was known that Earth is a globe for thousands of years, the notion that it orbits the Sun rather than the other way around was revolutionary. Greek astronomer Aristarchus of Samos proposed this idea in the 3rd century BC, but it wasn't until the 16th century that Nicholas Copernicus's heliocentric model gained traction. Copernicus argued that the Sun, not Earth, was the center of the solar system. However, Galileo's observations eventually supported Copernicus's theory, marking a pivotal moment in the advancement of astrophysics. Copernicus's work, conducted with rudimentary tools, fundamentally changed our perspective on the cosmos. Do you agree with our picks? Check out this other recent video for more insights.